right, so in Chapter 10, we're just going to be continuing some of the same ideas we've been learning in Chapter 8 about linear regression. I'm just going to show you kind of what happens when things don't work out well. So for this particular data set, I have the year and then the population of the United States in millions. And I just really fast want to make you aware of one thing that's often done. You'll see this definitely on the AP test. Years are very large numbers. So it's often done that we do the years since a certain number, like 1800. So in 1800, it's been 0 years since 1800. In 1825, it's been 25 years since 1800, and so on and so forth. Anything we do will work out the same. It just makes the numbers a little smaller, a little easier to deal with. So I'm going to ask you to construct a scatter plot of this data. I put my years in L1, and I put my population in L2. I always like to keep track of where I have my data. So you should make a scatter plot. If you don't remember how to make a scatter plot, you should go back and watch that from Chapter 7. At this point, you should probably pause, enter the data, make the scatter plot so you can check your work with mine. And this is the scatter plot I got. Now remember, we are looking to see, is this scatter plot linear? Well, I get students argue about this one. Some say, yeah, it's close enough if I'm at the back of the room squinting. And other students say, no, I'm definitely seeing a curved shape. Well, okay, so this one might be up for debate. We can settle it for sure by doing our secondary check. And that secondary check is to create a residual plot. So I've also constructed that for us. Again, we learned how to do that in Chapter 8. So here's my residual plot. Remember here, I'm hoping to see no shape or structure. But wow, I mean, this is awful. That's a very pronounced U shape. So this residual plot, terrible. What does that mean? That means this up here was actually not linear. That means my data set is not linear. It's not appropriate to do what's called a linear regression. Now, before now, we might have just thrown the problem away, throw it out the window, say, well, there's nothing we can do. But there is. And this actually happens to scientists a lot. So I'm going to show you one method they use to deal with their nonlinear data. We're actually going to be transforming the data. There are some common transformations that are talked about in your textbook. And when it says y, we're doing this to each value in the y data set. So for example, square root of y means I square root each y number. Log y means I take the logarithm of every y value. It makes me some new numbers. The ones where we have 1 over y or 1 over the square root of y, these could be positive or negative. Either way works. And doing something to the x variable should be last on our list. Usually transforming y is sufficient. And taking the log of both, yeah, definitely last on our list. Please stick only to these transformations that I've given you and that are in your textbook. Don't pick other weird transformations. So oftentimes I have students say, Ms. Curtis, well, we can't change the data. That would be cheating. It's not cheating. We do it all the time, especially in science. Think of when you've been asked to take miles per hour and convert that to kilometers per second. You're actually transforming or just rescaling the data. That's what we're doing here. So not cheating. It's going to feel like cheating, but it's not. And we stick to trying to make things linear because it is much easier for us to use and understand. Our brains have a much harder time interpreting and explaining curves. So I'd like to go ahead and try that data set that we started with, right? Hopefully by now it's in your calculator. We have the years since 1800 along with the population. And just for fun, we're going to try taking the log of the y variable. Now, I know you're panicking, Ms. Curtis. I hated logarithms. Okay, that's fine. I'm going to show you how to do it without remembering anything about a logarithm. I have a nice log button right by my 7, so I'm just going to push log, and I want to take the log of every y value. Well, please remember, our y values are in L2. So I'm just going to take the log of all of my L2 stuff. Okay. Now, if I push enter, it will compute those all for me, and I could write them down and create a new list. But I'm actually going to have my calculator help me with that too. I'm going to go to the store button. It's kind of kitty corner from the one store. Makes a little arrow on my screen, and I say, hey, calculator, when you're done with all these logs, would you please put it in a new spot for me? And I like to use L3. So if I push enter, you'll notice I have now a whole bunch of logarithms, okay, a whole bunch of new different crazy numbers. And if I look, those are actually in my L3. That's pretty cool. All right, so might be good for us to maybe just jot down L3 has the log of y, just to help us remember. All right, so now I can go and see, did that help me at all? Let's create a scatter plot so I can see if this is now going to be a linear relationship. So I'll go ahead and graph my L1, those are my years, and instead of graphing L2, I already did that, it didn't look very pretty, I'm going to graph L3. So I'm now graphing my year with my log y's. Let's see what we get. Wow, that looks a little bit better to me. Okay, so seeing maybe still some curving, maybe a little bit better. So my second choice now, I'm still not sure, I should do my double check, which is my residual plot. Now I can't skip straight to doing a residual plot. My residuals are still from the L1, L2. So I need to run a new linreg of my L1 and my L3. Okay, I'm doing a linreg for this new situation. It comes through, that's what it looks like. I'm not going to worry about this screen. I'm going to go back to graphing. And this time I'm going to graph my residuals from this new relationship. Okay, crossing my fingers, I'll do a zoom 9. And voila, I have a upside down U shape. That's still terrible. So what have we learned? Well, we've learned that taking the log of y is still not linear. So it didn't really help us. Okay, fantastic. Let's try something different. I know what you're thinking. You're thinking, Miss Curtis, oh, how many things do we have to try? Well, I'll help you out. This next one is about as good as it gets. So instead of taking the log, I'll do the square root, something maybe a little less terrifying. So if I say I want to square root, now I don't want to square root L3. That would be square rooting logarithms. That just sounds horrible. So I'm going to square root my L2, my original y data, and I'm going to store that in L3. I don't really care if I record on the top of L3. I don't need it anymore. All right, so go ahead and push enter. That'll run it through for us. I'm going to create my scatter plot of L1 with L3, and we'll see how that one looks. Wow, that looks beautiful. Look at how straight that is, especially compared to what we had before. Okay, I still should do my double check, so I'll calculate a linreg with my years and my now square roots. Okay, there it is. Let's double check my residual plot to confirm that I've made a good choice here. Crossing my fingers, hoping this one looks a little better. All right, and here we go. Ooh, still not really beautiful. Better. I don't have that distinct U shape. I have now maybe a little more like a W. This actually turns out to be the best that I can come up with for this data set. So it's, kinda better. And you know what? Sometimes we can't find something that's perfect. Sometimes a linear relationship is not a good explanation. So we'll be happy with the best we can get. So it was mostly linear. The scatter plot looked great. The residual plot was very questionable. When I did the years with the square root of the population. And now I could go through and actually identify an equation. Let's go ahead and do that real quickly. So So if I quit this, I still have my lin reg on the screen. So see if I can keep these both up there. Instead of my y being the population, my y is now the square root of the population. And it's 1.47. Really doesn't want me to have those both open. Plus 0.07 times the years. And remember, I did years since 1800. Of course, I'll put a little hat on top of that to remember it's still predicted. So really what we're doing when we go through this process, I know it's long, I know I did it fast, so we'll be looking at it again. But what I'm doing is I'm checking the scatter plot. It should look linear. If it looks linear, I'm going to keep going. If it doesn't look linear at all, I'm going to try a transformation. Sometimes you can't tell just from the scatter plot. So that's when we run our lin reg through the calculator. We don't do anything with it. We just have the calculator compute it. So this is just a calculator step. And then we check the residual plot. We're looking for no shape. That's what we're hoping to see. If there's no shape, then we're like living in chapter 8, right? We're happy little campers. We can write down our equation. We can make predictions. We can interpret the slope and the y-intercept. But if we do see a shape, right, we're really sad because then we need to try a transformation. And the whole process starts over again. We try a transformation. We check the scatter plot. If it looks okay, we run the lin reg and we look at the residual plot. If we still see a shape, we go back to the beginning. We try a different transformation. Now, before you panic that this is going to be awful and terrible, please hang on. We will walk through this some more. I know this process is complicated. And then in the next video, I'm going to give you the good news about what you will and will not see on the AP test about this topic.